Hey folks, I want to talk to you about equations, and this time it's going to be about slope-intercept form. So we start off with a little bit of notes here, and it's important to know that when you're using slope-intercept form, it's probably because you were given the slope and the y-intercept. That's because slope-intercept form has a lot to do with the slope and the intercept. It just makes sense that way, right? So my slope is the m right there. That's my slope. And b is my y-intercept, often written as y-int, and that is wherever I cross my y-axis. So like if this were my line, I'd cross here at say 2. My y-intercept is 2. Let's look at an example. So if I'm given this equation, 3x minus y equals 1, solve for y using the properties of addition and multiplication, then I need to graph it. So what they're really asking, if I'm solving for y, is to put this into slope-intercept form. So I'm going to move that form. I'm just going to write the exact same thing down right here. And I need to solve for y. They even told you use addition and multiplication. So getting y by itself, let me subtract 3x. Right? So I'm going to subtract my 3x on both sides. Now I have negative y equals 1 minus 3x. But I need to get y by itself. That's what they said, right? Solve for y. So now I need to get rid of that negative. I can do that by multiplying or dividing by a negative 1. So let's divide by a negative 1. And that has to happen to everything everywhere. So now it's a positive y. But 1 divided by a negative 1 gets me negative 1. Negative 3x divided by a negative 1 is going to get me a positive 3x because there's double negatives. Now if you recall from this slide, my equations usually always look like y equals mx plus b. So my x stuff, then my number. So here I need to do the same thing. So I'm going to have y equals 3x minus 1. I literally took that whole piece and just shoved it in front of my 1. That's okay. That's called the commutative property of addition. So that is my equation in slope-intercept form, but now I need to graph it. My y-intercept is the thing to the right with no x's attached, negative 1. So I literally go to my graph. I need to change my color first though. Go to my graph and put a dot right on my y-axis. That's this one that goes up and down. And that one's my x at the negative 1. From there, I need to use my slope, which is 3. And I can always put whatever that slope is over 1 if it's not a fraction already. So that means I'm rising 3, running 1. Rise 1, 2, 3. I'm going to put a little x there. To the right, 1. So this is my dot. Then I go up 1, 2, 3, over 1. And I can also go the opposite direction. So if I start at any of these dots, I could also go down 3 and then to the left 1. I could do the opposite of both of those numbers. And I'm going to try and draw a straight line through all of these. Not too bad, I think, right? And then arrows on the end. That's how I graph it, right? Starting off with my y-intercept and then using my slope to go from there. Now, I need to graph this one. It's already in slope-intercept form, right? Y equals mx plus b. There's an x right there. It looks a little bit different, but this could also be written like this. Only difference is instead of that x being on my numerator, I just pushed it to the right. So that means my slope is 2/3 and my y-intercept, my b value, is 1. If my b value is 1, that means I crossed my my y-axis, at 1. And I remember that like y has a big long tail. So it has to look like that. And then I have my slope, which is rising 2, running 3. So I go up 1, 2, and then to the right 1, 2, 3. Put my nice big dot there. And I could go up 1, 2, and go to the right 1, 2, off the page just a smidge, 3. And then I could also go the other direction. I could go down 2, and then to the left 1, 2, 3. And you can see that that still follows my nice pretty pattern. And let's try and connect those dots. Ooh, a little bit better than the last one even. Getting better. Okay. There's my graph. All right, this one has a little bit of steps here, right? Finding intercepts. Finding intercepts altogether. If I'm finding y-intercepts, I substitute a 0 in for x, and then I solve for y. if I'm solving for x-intercepts, I'm going to substitute a 0 in for y, then solve for x. Now, if that sounds confusing, usually we only care about y-intercepts, but if you end up with the wrong one, you'll notice that in a second. So let's do an example. I'm finding x and y-intercepts. I know I have to plug a 0 in. Let's plug a 0 in for x first, okay? Plug a 0 in for my x. So I'm going to have now y equals 2 times a 0, plugging in a 0 for my x, minus 6. What is 2 times 0? Still 0. And what is 0 minus 6? Negative 6. So y equals negative 6. That's my y-intercept. Has to be, because this is y equals something. So that means, should put a graph on here, I cross my y-axis down here at negative 6, because y equals negative 6. So that's definitely my y-intercept. Now, I'm going to substitute a 0 in for my y. So 0 equals 2x minus 6. Let's solve for x. It's my only letter, so I have to. I'm going to add 6. 6 equals 2x. I need to solve for x still, so I need to divide by 2. So now x equals 3. That has to be my x-intercept because it's x equals. And that means I cross over here at 1, 2, 3. Not quite drawn to scale. Boom. There's my line. Nice and pretty. Alrighty, folks. That is all I have for you. I hope all of you have a great rest of your day.